Extraction of pepperine from Pepper nigrum done by Sumant A. Vignesh OR, BTech Chemical Final Year. Guided by Mr. Y. Santosh Kumar, Assistant Professor, Department of Chemical Engineering, Veltech High Tech, Dr. Rangarajan, Dr. Shakuntala Engineering College. Area of project. Extraction of pepperine from Pepper nigrum is a process which is done in order to reduce the expensive treatment of cancer and some major illness. Drugs required for these medicines can be prepared in an economical way by using solvent extraction process. Objective. The objective of the project is to extract pepperine from Pepper nigrum for its anti-carcinogenic property by solvent extraction. Introduction to pepper. Pepper consists of major alkaloid 3 to 9% in black pepper. Pepperine is one of the most promising bioenhancer till date. A bioenhancer is an agent which increases the bioefficiency of a particular drug with which it is combined. Pepperine increases the bioavailability of drugs like barbiturates, curcumin, dapamine C, phenylenediol, amoxicillin, etc. Previous methods used for extraction suffers drawbacks such as poor extraction efficiency, expensive isolation methodology, etc. Hence, a simple, rapid and effective method has been studied by using various solvents. Isolation and purification can be done by using chromatography methods. Choice of solvent. The solvent which has to be used in the Soxhlet extractor has to be selected based on the CDERE and CBERE of Food and Drug departments. Based on the toxicity, the solvents are classified into as Class 1, Class 2 and Class 3 solvents. Solvents in Class 1 should not be employed in the manufacturing of drug substance and drug products because of their unacceptable toxicity of their deleterious environmental effect. Class 2 solvents should be limited in the pharmaceutical products because of their inherent toxicity, whereas solvents in Class 3 may be regarded as less toxicity and of lower risk to human health. So Class 3 solvents are normally accepted in the pharmaceutical industries. So finally, in the pharmaceutical industry, only Class 3 solvent should be used. Method of extraction of pepperine by using Class 3 solvents. Based on the solvents present in the Class 3, extraction process done by using the following selected solvents. Extraction of pepperine by using ethanol as a solvent is the first step, and the second one is 1-propanol as solvent. Procedure for extraction of pepperine by using ethanol is shown in simple 4 stages. The first stage is add 10 gram of pepper powder extract and 150 ml of ethanol in Soxhlet extractor for 2 hours and made it to run for 2 hours. The solution which is obtained is made to filtrate and concentrate so that the solvent and the extract has been completely separated. After the second stage, add 10 ml of 10% of alcoholic KOH was added and filtrate with a continuous stirring. And the final step is the insoluble residue was filtered and the alcoholic solution was left overnight and filtered through a membrane filter. And the third step is done in order to remove the resins which is found out in the extract. That is the 10 ml of 10% of KOH is added to remove the resin. This is the Soxhlet extractor as shown. The first arrow mark represents the condenser and the second one is the thimble where the feed has to be placed, and the final arrow mark represents the round bottom flask where the solvent has to be placed. While selecting the solvent, the boiling point of the solvent and the melting point of the compound which has to be extracted, which is placed in the thimble, should have a large difference. That is, here the ethanol boiling point seems to be 178 degrees and the melting point of the compound, that is the pepperine, found to be 131 degrees Celsius. So there is a large difference between the solvent and the melting point of the compound. So there is a chance of compound to be escaped if the melting point and the boiling point of the compound is nearer. The first arrow mark represents the condensed ethanol vapor which has been obtained from the round bottom flask which is placed at the bottom of the Soxhlet extractor, and the second one is the extract which has been obtained from the feed, that is which is placed in the thimble. The experiment found to be completed when the brown color fades away, which represents the entire solute from the mixture is been completely removed out, so that when the brown color fades away, it shows that the entire solute has been removed from the feed. After the first stage, the extract which has been obtained is made to filtrate, and after the addition of alkali KOH, the insoluble residue was filtrated and left overnight in order to remove the resin from the extract. The final step is the extract which has been obtained by addition of alkali KOH is given for the analysis part for the detection to find the presence of piperine found in it by using UV spectrophometry analysis. The graph obtained in UV spectrophometry analysis by using ethanol as a solvent as shown. Here a lot of maximum peaks has been obtained, as these peaks are due to the presence of various components in the extract. And here the main compound piperine has a maximum peak value of 340 nanometer. We successfully obtained the 340 nanometer at the maximum peak value. These are the values which is obtained by using UV spectrophometry analysis by using ethanol as a solvent. Here we obtained maximum peak values in various nanometer, and our product piperine has a maximum peak value of 340 nanometer. We successfully obtained at 340 nanometer range, we obtained the maximum peak value. This confirms the presence of piperine in the extract. This is the graph obtained by using 1-propanol as a solvent. The extraction method by using 1-propanol is same as the extraction done by using ethanol as solvent. And here the graph which has been obtained has a maximum peak value, and our product piperine is found to be at 340 nanometer successfully even in 1-propanol. These are the values which are obtained while running UV spectrophometry analysis by using 1-propanol as solvent. Here we find maximum peak values at a various nanometer, and at 340 nanometer we have obtained the maximum peak value, which represents the presence of piperine in 1-propanol extract also. Thus, finally, the extract obtained from the ethanol and 1-propanol as a solvent found to have the presence of piperine. Now, the extract is analyzed with the HPLC for the determination of percentage of piperine found in the extract. HPLC result. Here, the graph shown in graph 1 and graph 2 represents HPLC result for both the extract, and graph 1 represents the HPLC result for ethanol as solvent, and graph 2 for 1-propanol as solvent. Here the graph 2 represents 1-propanol has a maximum area under the curve when compared to the HPLC result for the ethanol. So experimentally we can say the area under the curve is greater for 1-propanol. Obviously the extract obtained will be larger for 1-propanol compared to the ethanol as solvent. Conclusion. The process of extraction was successful and a considerable amount of extract was collected and identified by HPLC. Thus, by using 1-propanol as solvent, the maximum amount of desired product was obtained when compared to ethanol as solvent. Compared to other methods, the novel method using 1-propanol proved to be effective in isolating piperine with higher yield.